Hello everyone. In this short video, let us learn the reason why the allopurinol is used to treat the gout. So as you all know, the gout is a condition where there is hyperuricemia, increased uric acid levels. The normal uric acid levels in males is around 3 to 7 milligrams per deciliter, and in females it is slightly less, that is 2 to 6 milligrams per deciliter. So if it goes beyond this level, it is called as hyperuricemia. So because of hyperuricemia, there will be formation of monosodium urate crystals, and they get deposited in the synovium and synovial fluid of joints. So because of this deposition, there will be inflammation of the joints leading to gouty arthritis. So gouty arthritis is the major symptom or clinical feature of gout. So usually the first metatarsophalangeal joint is the area which is affected by the gout. So this is a great toe joint. Now what is this uric acid? Uric acid, as we all know, it is the end product of purine metabolism. The purine nucleotides are of two types, adenine and guanine. These are the purine nitrogenous bases, and when they are broken down, ultimately they produce uric acid. In the pathway of degradation of purine nucleotides, we have to remember one key enzyme that is called as xanthine oxidase, which catalyzes the last step, that is conversion of xanthine to uric acid. So xanthine oxidase is the rate limiting enzyme or the key enzyme in this pathway. Now let us learn how the allopurinol actually decreases the symptoms of gout. So the allopurinol acts as an inhibitor of the enzyme xanthine oxidase, which is the rate limiting enzyme of the purine degradation pathway. So this is the last step catalyzed by the xanthine oxidase, where xanthine is converted to uric acid, and this particular enzyme can be inhibited by a chemical substance called as allopurinol. So allopurinol structure is similar to the xanthine structure. So allopurinol competes with the xanthine in order to bind at the active site of xanthine oxidase. So when the xanthine oxidase is bound with allopurinol, it is inhibited. So this particular mechanism is also known as an example of suicidal inhibition. Why? Because the chemical substance allopurinol gets converted to alloxanthine by the same xanthine oxidase enzyme, and this alloxanthine, which is a product of this reaction, is much more potent inhibitor of the xanthine oxidase itself. So it is like xanthine oxidase produces alloxanthine, and alloxanthine inhibits the xanthine oxidase. So this is like a suicide. So here the inhibitor makes use of the enzyme's own reaction, and in suicidal inhibition, the structural analog, that is allopurinol, is converted to a more effective inhibitor with the help of same enzyme which has to be inhibited. So that is alloxanthine. So thus the mechanism of action of allopurinol to treat the gout is it competitively inhibits the xanthine oxidase, and one of the subpart of the competitive inhibition is suicidal inhibition. So allopurinol getting converted to alloxanthine, which is a much potent inhibitor of the same xanthine oxidase enzyme. So this is the best example of suicidal inhibition.